All right, so introduction to functions. The concept of a function is one that is very important in mathematics. The use of the term is very specific and describes a particular relationship between two quantities. One of the quantities is called the input and the other is called the output. We talked about this a little bit when we were interpreting our graphs. The input is the independent variable and that goes on the horizontal axis. The output is the dependent variable that goes on the vertical axis. And a relationship between two quantities is called a function if each input has exactly one output. So each input value is associated with exactly one output. When you think about our graphs of like time over distance, for any time that you pick, you can compute exactly one distance that's associated with it. You wouldn't say, oh, after 10 minutes, Yannick was 5 miles away and 10 miles away. That doesn't make sense. You can't be 5 miles and 10 miles away at the exact same time. So each time corresponds to one distance. That makes that a function. In general, each input should correspond to exactly one output. Okay. Why do we care about functions? Imagine that you are a nurse working in the emergency room of a hospital. A very sick person arrives. You know just the medicine needed, but you are unsure of the exact dose. First, you determine the patient's weight, which is 200 pounds. Then you look at a table, or the table to the right, and see the given dose information. Okay. Now, what if you're given this table? Well, it says to the right, it's below. What if you're given this table and it says, oh, if a person weighs 200 pounds, you should give them 10 milliliters of medicines. And then the other line says you should give them 100 milliliters. That's a big difference. Very big difference. Which one is right? We need to have a function that tells us exactly what weight corresponds to the amount of medicine. This does not give us a function. This is giving us two different outputs, which will lead us to concern and which would put the patient in a very dire situation. We might give them the wrong amount. So it's important that our functions have one output for each input, especially for these types of problems that we're going to be doing in class that are real world examples where we're applying the function techniques to it. So this is an example of why you can see that it's very important that each input matches to one output. All right, going to our example, number 11. Let's investigate the functional relationship between two quantities, the numerical grade and the letter grade. First, let the numerical grade be the input and let the letter grade be the output. So you input your numerical grade and that determines your letter grade. All right, an input of 95 has an output of an A. A 92 is an A, an 85 B, 73 C. Does this represent a function? Does each numerical input correspond to one letter output? And the answer here is yes. This is an example of something that would be a function. Every numerical grade from 0 to 100 has a letter grade that corresponds with it, and only one letter grade. You can't say, oh, I got an 80. That's a B plus and a B minus. No, there's only one letter grade that's associated with it. It's a B. All right, very important here. There are several different ways we can represent functions. The above is an example of representing a function with a table. When we have a table, the column on the right left usually represents the input. The column on the right represents the output. Okay. The way that we have this written, if the numerical grades are the input and the letter grades are the output, this does represent a function. However, what happens if we switch these? So in the next table, we're going to say that the letter grade is the input and the numerical grade is the output. Does this table represent a function? Does each letter grade correspond to one numerical grade? The answer to that is no. We can see very clearly that the grade A can be a 95 or a 92 or 93 or 94 or 99 or 98 or any decimal in between there. Okay, so there are lots of different numerical grades that correspond to the letter A. That means that the input of A has multiple different outputs that it goes to. Here are just two examples. That is a problem. That means that this does not represent a function. So when you're looking at a table, you want to look at your inputs. If there is an input that is repeated, if it goes to two different outputs, it's not a function. All right, so in addition to knowing for a function, each input goes to one output, some other terminology you should know is, I mentioned it earlier, independent versus dependent. Your input variable is called your independent variable, and your output variable is called your dependent variable. So in the language of functions, the independent variable is the input, and the dependent variable is the output, and the output depends on the input, or we say the output is a function of the input. Okay. Now we get to try one of these. The cost of making copies. Okay, determine which variable is the independent variable and which is the dependent variable. So the cost of making copies is a function of the number of copies you're making. Remember, it says, I'm going to highlight, I think you highlight on this thing. The dependent variable is a function of the independent variable. So here it's saying the cost, I have coffee on my brain, y'all. The cost is a function of the number of copies, okay? So that means the cost depends on the number of copies, okay? That means the number of copies that you're making would be the input or the independent variable, and the cost would be the output or the dependent variable. So for here, what is independent? Our independent variable, spelled that all wrong. Independent variable would be the number of copies, and the dependent variable would be the cost. And hopefully that makes sense. If you're making copies and somebody says, how much does it cost? Well, it depends on how many copies I make. So if I tell you how many copies I'm making, then we can figure out the cost. For part B, the tuition for a semester depends on the number of credits the student takes. Okay, so tuition depends on number of credits. That means that the independent variable is the number of credits, and the dependent variable would then be the cost of tuition. So if you know how many credits you're taking, then you can use that to calculate what the tuition would be. On to function notation. So once we determine that something is a function, we can write it in function notation by writing the function name, which is usually a letter like F or H or M or R, most of the time F. And then we write the input in parentheses, or the input variable in parentheses, and that equals the output variable. So the statement f of x equals y would mean that the function name is f, the input variable is x, and the output is y. And then x comma y would be an ordered pair that represents the input comma the output. Okay, so you have that the output, where is that? I like to write it this way. We had in words before that the output is a function of the input. In function notation, the output, which is usually y, equals a function of the input would be f of x. So when you see y equals f of x, this is just a way to write function notation. The x is the input, the y is the output. All right. If we want to evaluate a function, that's what we're going to do in example 13. So you see we have f parentheses 2, that's where at f of 2, and then f parentheses -1, that's f of -1. The number in parentheses represents the input. That's the number that we're going to plug in for x, and then we'll simplify to see what the y should be. Our function here is 2x minus 5. So when x is equal to 2, we get 2 times 2 minus 5, which is 4 minus 5, which is -1. So f of 2 equals -1, and we have the ordered pair 2 comma -1 on the graph of this function. Okay. What about f of -1? When we plug in -1 for x, we get 2 times -1 minus 5. That's -2 minus 5, which is -7. So f of -1 is -7. Or when we have an input of -1, the output would be -7. In example 14 here, we are given not the function rule, but we're given a bunch of ordered pairs for a function g. So g of x is the set of ordered pairs 1, 3, 5, 2, 8, 3, and 6, -5. Remember, for an ordered pair, the first coordinate represents the x value, the second coordinate represents the y value. So for number 1, g of +1, we want to go to the ordered pair that has an input of 1 and find the corresponding output. We see that 1, 3 is a point, so that tells us that g of 1 equals 3. Okay. All right. Now for part B, notice the difference between part A and parts B and C. In part A, we're given the number in parentheses, so we're given the x, and we have to find the y. For part B, we're told that g of x equals -5, and we have to find the x. So for part B, we're given the output, the y, and now we have to find the x. So for B, we want to go to a problem that has go to the ordered pair that has an output of -5. That would be this last ordered pair, 6, -5. This shows us that when x is equal to 6, y is equal to -5. So our answer here would be x equals 6. Okay. Any questions about B? And then last one, C, we're doing the same thing as B. We're given the output, g of x equals 3, and then we want to figure out for which of these ordered pairs or for what x value is the output 3. And we see that that matches up with this ordered pair, 8, 3. So x would be equal to 8 when g of x equals 3. When you're plugging in an x value, yes, you can only have one y value. But when you're going the other way, when you're given a y value, it can match with more than one x, which is what we see here. Let me highlight this in a different color. Boom and boom. For this one, 1, when x is equal to 1, we also get an output of 3. So yes, 1 would also be an answer. This can have 2 answers, 8 and 1. Problem 15, the function v of n is shown below, gives the value of an investment in thousands of dollars after n months. So the table is given to us a little bit different. The first row represents the inputs. The second row represents the outputs. Oh, and that kind of gives us the first thing. Identify the input quantity. That would be n, the number of months. So if you put in the number of months that you're investing, this function will spit out the value of your investment in thousands of dollars. So the output is V, which is the value of the investment. Okay, write a sentence explaining the meaning of the statement V of 1 equals 2.31. Remember, this 1 represents the input, and this 2.31 represents the output. So this is saying after the input is 1, after 1 month, the value of the investment is 2.31 thousands of dollars. So $2.31 thousand. You can also write that as $2,310 if you want to. But the input tells us the number of months, the output tells us the dollar amount in thousands. So you just want to write those two in a sentence, a complete sentence, when you're asked to write the meaning. All right, two more parts here. Determine V of 3. Is it in the table? Yeah, it's in the table for us. So when the input is 3, what is the output? From the table, we can see that V of 3 equals 5.23. Now the fun part. Well, what does this mean? This means that after 3 months, the value of the investment is $5,230. And you can write it as either $5,230,000, use a dollar sign, or you can write it as $5,230. Either way. All right, so notice the difference between, these aren't labeled, but what we're asked for this last part that we just did, and then what we're being asked in the next part. For V of 3, we're given the input, we're asked to find the output. For the next part, V of n equals 3.02, we're given the output, we're asked to find the input. So let's go back up to the table. For which input is the output 3.02? There's only one of them this time. That is when the input is 2. So we would say that n is equal to 2. And what does this mean? This means that after 2 months, or I'll write it the way that it's given, the value of the investment is $3.02,000 or $3,020 after 2 months. So the 2 tells us the number of months that it takes for the value of the investment to reach that amount.